What is up, YouTube? So Docker is a really popular tool. It's basically a standard in the world of engineering. However, you can easily use all these features of Docker for building an end-to-end data science project. I will provide a full tutorial how you can build a data science project from scratch using Docker. It will include all the components of such as environment, building models, keeping data, where to keep data, version control, deploying these models, building API. It will consist of a full end-to-end project where you can package the whole data science workflow in a single place. I will also provide a full source code on my GitHub repo. The link will be down in the description. So before we move forward, let's quickly look into some concepts and terminologies of Docker. So Docker is an open source platform to help you develop, build, and productionize your code as part of containers. So you can think of containers as lightweight abstraction of virtual machines, basically. Even though they would run on top of virtual machines, you can think of them as a lightweight virtual machine, which have their own CPU power, RAM, as well as networking capacity. And then you can kind of package this whole code with the dependencies in place inside of those containers, which basically never breaks. So therefore, after you package everything together, these containers basically run reliably anywhere, regardless of the environment they're facing, regardless if it's a VM or a hardware machine or even your local machine. So the next concept is Docker image. So basically, to start a container, you need a Docker image. So you can think of an image as a blueprint of the container. So it basically contains all the dependencies, all the codes you're pulling in. So it's basically like a script, which uses basically a Docker file to lay out the whole Docker image as a blueprint. One of the other key features of Docker is that you already get these pre-built images already set up for you to use in Docker Hub or any other platform. Basically, you can just pull these images and use them as per go. Images can be like MySQL image, which runs a fully MySQL database within it. Can be an Ubuntu image, can be an image which already has Python and the dependencies installed with TensorFlow. So all these images kind of exist as a part of the community and the open source of Docker for you to use. The next is Docker file, which contains YAML-based instructions with commands such as run, cmd, where you kind of laying out the whole blueprint of an image. So you build the image using a Docker file, basically. Docker file consists of all these instructions. So basically, you can consider a Docker file like a DNA to a Docker image. So let's look into why data scientists should use Docker in the first place. First of all, considering one of the main requirements is, as I mentioned, environment issues. So a lot of the times people develop their code in a specific local machine. They install pip packages, they install some other dependencies, and they say, hey, it works, and then they export this code, and then they save this code as Jupyter Notebook and share it across. But when someone else tries to use this code, a lot of the times they face issues with all these dependencies which do not exist. A lot of the times the versions of the dependencies are an issue, or the existing local environment is using some older version of dependencies. So that's where the problem comes in. Sharing across teammates all these Jupyter notebooks is not very convenient. One of the another benefits is there's a lot of these pre-built images already exist, basically with the right dependencies installed. Sometimes you need TensorFlow, they already come packaged as part of the whole image, so you don't need to worry about the installing dependencies as in general. Another point is that all the cloud platforms kind of enables you to use Docker. Especially when you're trying to scale stuff, it's very easy for you to deploy Docker images on cloud platforms nowadays. Services like Cloud Run, Elastic Beanstalk in AWS can really help you just push your image, the whole thing together, and deploy it in a VM very quickly. As a last point, productionization is very important. And once it's developed in a Jupyter Notebook, you can basically package all these together, productionize your code with Docker. I think that's a very essential part because you don't want your code to break because of issues, dependencies, or some code is missing. And that's what I'm going to show as a part of this whole repository I have. As I mentioned, we're building a full-fledged data science project. So we're Dockerizing our data science project. There are a few components, as I mentioned previously. First one is data. That's where all the data kind of exists. There's Docker, where all the Docker related code exists. There's models, where you kind of like check in and save all the models like from your Jupyter Notebook. And then there are all the notebooks. So from Docker, you're creating two containers. First is fast API for the APIs, and then you're creating another container, which is Jupyter Lab. So yep, let's see if things are running. So it took me some time to kind of build this up. I faced a few errors on the way, so maybe I'm just going to include while I'm going through the code. So yeah, this is essentially the main structure to it. You can directly use it as is. I placed in sample files. Just you can reuse it, repurpose the sample files the way you want it. And then I also have the sample files like this as txt, so that it's committed into the Git repo. You can directly access. There are 2 Docker containers mentioned with their own Docker files, requirements, and whatnot. And then there's like the output of the models, and the models are being used in the API. So yeah, let's just go through it. So I think let's start with the first thing. The way to run is to run this shell script. With the shell script has a simple command docker compose.up. So let me just go into the folder and then run this one, docker ds project, dockerize ds project. Okay, I'm inside the project. There are 2 Docker containers. Let us build the Docker images at first, one by one. So let's move into the fast API. Let's move into Docker fast API folder, and in the Docker fast API you can see there's a build script already for you to use. So you can just do sh docker build. Essentially this file is just a small shell command, docker build t, with the image name and the code and the version. So yeah, let's just run it and see what happens. I've already done this process, so mostly it should be pulling out data from cache. So yep, you can see it was successful in building the Docker image. So you can see all the 4 different steps of the Docker file. So let me just walk you through the Docker file also. So we are taking a base image Python 3.8 from this one. It is just a Python 3.8 image we're taking, and then as a next step we just initialize like which repository, which folder we are using as work directory. This is what the command is about. We are copying the requirements.txt file. All the requirements kind of are in this folder, you can see. So we just want fast API and scikit-learn. Fast API is essentially like a pip library you install and use it very easily. It's anyways very simple to run it on local, but a lot of the times you need other dependencies like scikit-learn within your APIs to call in the prediction function. So this is what it is about. So it's here, and then you install these requirements in the next step, on 4th step, and then the 5th step is just a command. When this container runs, it's going to run this command. So it's basically it's essentially the same command which fast API says you need to run the app. So we're running the APIs on 8000 port 8000. So yeah, so that's about it for this image. So we, as you can see, we haven't moved any code here. We haven't moved any, like as in the code files. This is going to be done by volume mounts. We are going to use volume mounts within docker compose.yml. I'm just going to go through it in a couple of more minutes. So moving on, the first image has been built, which is good to go. Let's look into creating the other image. Moving out of this folder, the fast API folder. Yeah, moving out of the fast API folder. Let's move into the Jupyter lab folder. And yep, it also has its own Docker file. And it's requirements.txt. These are the requirements we're trying to use, matplotlib, etc. Docker file is all like 5 steps. So we're using a mini conda base image, creating a work directory, requirements. The drill is very similar. Instead of using, because we're using this mini conda image, instead of using pip, you're using conda to install all the requirements which are mentioned in this file. Yep, all these requirements are being installed. And then one of the other ideas from my end was to also integrate it with Google Cloud SDK. So basically, in case you want to use files, pull out files from Google Cloud storage, basically helping you to install the command line tool. So from there, you can just do GCS ls or GCS cp to copy all the data from there to here on your local. So yeah, this is what it is about. We also need to pass in the JSON key for it, which we are going to do later on through Docker Compose. Next step is the command. The final command, when the container is being created, it's going to run this Jupyter lab. Essentially, Jupyter lab is also a pip framework. So after it's installed through pip, you can just call it. Everything kind of works out and you just do allow root, so which allows you just to access it without any credentials. Essentially, you're running it on local, so it doesn't matter yet. So yeah, this is the second image. Similar process. I have a shell script because it's easier to keep a shell script and not remember all the commands. I think I kind of prefer doing this way. Docker build sh. Sorry for the interruption. One thing I wanted to point out, if you're gaining value out of this video, definitely hit the like button and subscribe to my YouTube channel. It really helps me a lot to push my content to people like you and promote my videos. This Docker image also has been built. So to see the image, you can do Docker images, image ls. This should work as well. So you can see these two images, or you can use this extension. I think I prefer to use this extension. So these are the images. You can see Fast API and then Jupyter Lab. So these are the images we just created, which was some time back. So yep, as a next step, we are going to run this image, both the images together, and see the whole flow. So yep, so I think it's best to move on to the run compose and then Docker compose. So you can see run compose is essentially calling Docker compose up, which is just a configuration file, YAML file, which has all the steps as in the configuration on how to run these containers. Okay, moving on to the Docker compose. I think this is like one of the important points in this whole project on how the whole thing kind of works. So let's go one by one. Let's go into the first service. So within Docker compose, you kind of lay out these different services. So you have a service tab called services, and then you have multiple services within it. So we're creating two services, as I mentioned, for two different images. So one is Jupyter Lab, another is Fast API. For Jupyter Lab, you can see there's an image because we already built the image. Usually this image actually comes from a Docker Hub or an image repository. The idea is you push the image to a repository, then it's usable anywhere in the world. For now, I'm just doing things on local, but you can push it on a repository and place the URL here, so it's very easily accessible. If you do it on Docker Hub, you can just place a simple URL. Creating a container name, I think I kind of prefer naming these containers because then it's easier to log into it and also check in the logs by just using the name. That's what I prefer. Passing the environment variables. Yes, so this is also another important point. If you need to pass any environment variables, you can do it using this, as in calling the environment tab. Within under the environment, you can place in the environment variables. Right now I'm leaving it as a blank, but basically that's where the JSON key for Google Cloud goes, and then it places the JSON key within your environment, and you can use Google Cloud within Jupyter Lab service. Okay, next is volumes. So this is also quite important. You need to look closely for it. So basically what's happening is I've created these three different folders. One is data, models, and notebooks. So this is the whole structure to the project, which I kind of foresee being like super usable. So you can see there's the data goes into the data folder. The data could be part of other cloud services such as GCS or AWS S3. You could directly access from there, or for some simple data, you can always copy and paste it here. Essentially, I have ignored, I place .csv under this folder as gitignore so that we do not commit it. But for sample, I've placed these text files for you to use. You just rename the text .txt to just .csv, so it will be usable. So yeah, this is where all the data exists, kind of a shared folder for you to use via Jupyter Notebook. Okay, and then the models goes here. So and then the notebooks goes here. All the notebooks are here. This folder is also part of the project, and then the models are under the /model folder. So all the threes are kind of mapped. The volumes are kind of mapped from local to the Docker image. So when I run it, I would be able to see all these together in a single folder within my Jupyter Lab. And yep, so this is all volumes. And then the next is ports. Essentially, when you run Jupyter Lab, it runs on port 8888, and then you need to just port forward it to your local so that you can just access like localhost in this port. You would be able to access this service but just by doing this. All right, so this is Jupyter Lab service. Similarly, Fast API service is very similar. We already created this image, latest version, creating a container name, environment. If you need any environment variables, that's a sample I placed here. And then there's two volumes being mapped. One is APIs. This API folder contains the main.py, which has the APIs in place. you place it under the code/app. Similarly, models, because the model is kind of shared between two, the idea is you create the models using Jupyter Lab in a folder, and it's being mapped to a folder within this container also. So it's basically being used across easily. And the models comes the models actually are committed here, and it's just being mapped here. And as a part, the APIs are exposed on 8000 port, and that's what you use to port forward. So yeah, this is essentially the two services being created. So let's just go ahead and run our containers from Docker Compose. So let me move out back from into the main folder. So after I'm in the main folder, I already have created, as mentioned, a shell script to run compose, so that I just do not need to remember these commands in future. So sh.runcompose.sh is going to create both the containers. All right, so looks like things are working because I already tested it previously. So yeah, you can see the fast API instance, the APIs are up and running, and you can see the Jupyter Lab, this is also up and running. So let me click on it, and let me just paste this in the browser. All right, so it's up. The Jupyter Lab container is up. Going back, you can see in a shell script, in a terminal, you can see if the Docker, by doing docker ps, you can see if both the containers are up. You can see two containers are up, fast API and the Jupyter Lab. So both of them are up for you to use, which is great news. All right, so when this is up, so let's go through both of them one by one. So I've also created a sample notebook. That sample notebook creates a model, and this model is being used in APIs for you to use, for you to serve them, basically. So the requirements are copied here directly in this folder. I'll not go through it. Then there are three more folders: notebooks, models, and data. So the data, so let's go through the notebooks. I created a simple linear regression notebook already. I copied this part from open source GitHub repo. I'm going to leave a link for that repo as well. But the whole process is that we are creating a simple linear regression algorithm using sklearn, a simple linear regression algorithm, and the training data is at salary_data.csv, which is this file .salary data, a simple file which says number of years of experience and the salary of a person. So the years of experience is X, and then salary becomes Y. So that's how like a very simple, like two-dimensional simple linear algorithm would work. And yep, so in this notebook we are basically training the model. First of all, we split the training set by training then split the data set into train and test set. Then we use the train data to fit the model, the regressor model, and then you can use it to predict the values on the test data set. So this is how the whole process works. And then this notebook has easily plotted this line, which is the regression model, as a part of the data set for you to see how the model is fitting really well into the data set. Yeah, for most of the data scientists, the process kind of ends here, where you create the models and then you share these notebooks with your colleagues for them to use. So as in for the next steps, what we are doing is we are just dumping the regression model, the regressor object, as a pickle dump. So we are writing into this path. So under models, we are saving this model, and then you can pick this up and read this again as a Python object and reuse this to predict. Yeah, this is the whole process of saving the model. After you create the model, you can save the model using pickle as a dump in a folder, models folder. So at the end of the day, your models kind of live here under this /models folder. They can be multiple models. As a shared folder, you can be used within the notebooks, and it can be used within your APIs. And thus we are moving into the next step, productionizing your models, provide them as service for other people or consumers to use or other colleagues to use easily. And that's what we're doing here. We're creating simple APIs using fast API, which will take in an argument as salary, and then it would predict using the saved model, the pickle model we saved, and it's going to show up, print the output. So moving on, so I already have created two parts on the APIs. One is slash, which is just a sample API route to see if things are working. So if I go to localhost 8000, you can see the my API is actually working, which is actually great. So moving on to the code is pretty simple. We just use this pip package fast API, create a simple object, and from that you can create functions which are essentially can be returned as API objects or API responses. So slash is the default route, and then I have created another API called predict salary, which is the predict API we're creating from our model which we just created, and then predict salary of an employee with age 23. This is what we're going to do. So after I call this, so essentially this will read the model we created using pickle we saved, and then it's going to read it and run the prediction algorithm and provide us the salary as a response. So this is like a sample workflow I have created for you to use now. So yeah, so moving through the code, you can see it's just a few lines of code. We are reading the model. When you call the API, it reads the model as from pickle, because pickle just serializes it and save it on disk, and you can just read it, pick it up. After that, you can just use to call the prediction function on the employee age coming from the argument here. And thus it will provide a JSON response as a predicting the salary of the employee with age, something like this. All right, so yep, so this is kind of simple template. I know like a lot of things are not as efficient. Like for example, this is not productionized save what we are doing. I think saving this model could be more efficient, even using pickle. Also, we are reading this pickle file every time we're hitting this URL. Probably we can move it out in some other function so that it's not calling and loading this object again and again. It's basically loaded into memory full time when the server is running. So right now it's just being called when this URL is being hit. If you really got value out of this video, definitely hit the like button and subscribe to my YouTube channel. It will help me promote to people like you.